how many rearrangements of the letters ahu are symmetric across a vertical axis of reflection. What does that mean? Axis. Axis means a line. Reflection means that we're reflecting across a line. Vertical line. So I'm putting these letters in a way so that if I have a vertical line that is like a mirror, then the letters in ahu are symmetric. Let's maybe try to draw an example of how this might look. Maybe I do this. O, 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 A, H. This is symmetric across the vertical axis of symmetry. You can see that all of the letters were chosen in a way where each letter itself is symmetric across, if I flip the letter horizontally, across the horizontal. You can see that each letter is symmetrical when I flip it across a vertical axis of symmetry. Now, actually, once you look at this, you realize that you really have no choice except for to put the O in the very middle. And so actually this question is quite simple once you understand what it says. What it says is that the O has to go in the middle, and then once I decide on these three, once these three are fixed, then that actually forces what these three are, because it's the mirror. So the only thing I need to ask myself is how many different ways are there to rearrange three letters? But that's something that you probably have seen before. If I have three letters, all of which are different, the number of rearrangements is just 3 times 2 times 1, which is 6. Actually, that's all there is to a question like this. And so the lesson behind this is that when you're looking at a question like this, the first is to not read it too quickly. If you read it too quickly and just try to find rearrangements of this with 7 factorial divided by 2 factorial, 2 factorial, 3 factorial, you'll be wrong. But apart from reading it correctly, the key is to see if you can find some nice fact, such as the fact that O has to be in the middle. And then from there, it becomes a routine question. That's all there is to say about ahu.